Good morning. Hi.
Good morning, everyone.
Good morning.
Thank you for joining at an appropriate time.
Philippe, I have just one question, just to clarify regarding the slides. You're going to manipulate
Yes,
the slide,
yes.
right?
I'll share all the slides, and I can share the mural if we use it to support the discussion. The speakers just need to tell me, next slide, and then I'll move everything forward.
Good morning. Good afternoon.
Good morning.
Hi.
The session hasn't officially started because I need to just grab a quick cup of glass.
Correct. So we have a couple minutes to just organize before letting in the audience.
Perfect. I'm just going to grab water so that my throat doesn't dry off. All right, be back. Yeah.
Meanwhile, Aurélie and Emmanuel, I see Emmanuel, you're here, right?
Yep.
Good morning.
Yep.
I have shared with you the link of the mural. Mural is the tool that we are going to base our discussion after your presentation. And I have prepared some sticky notes based on your slides. The sticky notes will be manipulated by some colleagues of mine. But if you want to access the mural, I have sent you the link. If you want, I can send it again, if this is helpful. But anyway, Philippe, I think it will be displayed on our screen, right? During the discussion.
I will share it during the discussion. So you just fill it out, and I'll move around if we focus on a different area. But yeah.
Great.
I'm assuming you know that Isabel is going to be joining soon.
Andreas, I think, is going to
Andreas,
join.
okay.
And Isabel just asked me if she wants, if we want her.
Okay, I have my list has Isabel listed as the other rapporteur, but I'm assuming you're more up to speed on who's supporting. I'm just going to write Rodan to quick email.
I am going now to ask her.
Oh wait, no, sorry, it's Josep that we're expecting. That's right, there was a last minute change.
Josep is going to be a little bit late.
Okay, that's if we're aware that's fine, then I'll just send an email to Roland.
Yes, I'm back.
Adila was just referring to the mural. So we are going to base our discussion on the mural, which will be displayed in our screens. But also, I have sent you a link to access the mural during the discussion if you want to. But the sticky notes that I have prepared will be manipulated by some colleagues of mine. So it's up to you to join or just to watch on the screen.
I've sent Roland an email, so once he joins, I think we can open it up to the audience. But we're still good in time. Okay. All the speakers are here now. We're only missing the other rapporteur, but you said he would be late. I do see Andreas just entered in. I'll let him in. So what I'll do is I'll open up the room to everyone. I'll share the slide telling everyone that we'll start at about 10:45. And then, yeah, of course, message me if there's anything you need during this. My chat is open. I'll be spotlighting each speaker during their session. And yeah, I think that clarifies everything.
Sure, thank you very much. Roland, hi. I just, before you joined, I just commented on the mural that we are going to use during our discussion, and you should have a link. I have sent you a link if you want to access, but anyway, it will be displayed on our screen, so it's not necessary. I wanted just to clarify.
I will then allow everyone in from the waiting room, and then Vicky, I'll leave it at your discretion to start us off when.
So you will tell me when to start.
You can start on the dot, or if you want to wait a couple minutes, that's fine. But I'll open everything up, and then.
I would start immediately when you see people coming in.
Okay.
I have a question.
Yes,
Yep.
please, Adele.
So the allocated time slots for the session, I think we have to, of course, time box it within the 10 minutes that we have been assigned. So as soon as the presentation is concluded, there isn't any Q&A session. That's done at the end of the session, correct?
So the thing is that from yesterday, I attended some sessions yesterday, and I think it's better if we probably have some questions. If we have questions on Slido, I will make these questions after your presentations, the 4 presentations altogether.
Oh, okay. So
if we don't, then we are going to proceed with the brainstorming and the discussion as planned.
okay, and that's also for 10 minutes, right? That's because I see the agenda is up till 12.
Yeah, but I when we were participating in the last sessions, I think it would be beneficial if you rather make your presentation shorter than exceeding 10 minutes.
No, that's clear. That's
I think
understood.
Yeah. Okay. Thank you very much, and I think we are ready to start.
Okay, great. Then I'll let everyone in, and yeah, whenever you're ready.
So good morning, everybody. My name is Vicky Harisi. I work at the Joint Research Center of the European Commission with a background on human-robot interaction, and I'm going to chair this session on AI for industrial automation and robotics. We have a great panel today with us in order to discuss the current challenges in standardization on this topic. What are the ethical considerations that are emerging in the industrial automation and robotics? We are going to map the existing and missing standardization efforts and to indicate probably some guidelines and next steps on how to proceed with the standardization in this area. So I would like to present the invited speakers today. So first, we have together with us Adil Amhad from Thermo Fisher Scientific, then Aurélie Clodig from Anity, Emmanuel Kahebwe from FDE, and Ronald Behrens from Fraunhofen IFF. So I will give first the floor to Adil. Adil, the Oh, yes. First, some practicalities. So we are going to use Slido in order for you, the audience, to make questions to our panelists. You should enter slido.com, search for standards for AI, hashtag standards for AI, and select Industrial Automation and Robotics room in Slido. You can also use the Zoom chat here to type in technical questions to the host, and we would like to ask you to to have your camera and audio off during the session. So I think we can start now with Adil. Adil, the floor is yours.
Thank you so much, Vicky, for the introduction. Good morning, good evening, good day to everyone. Just start with my introduction. And I think we can go into the next slide. Yes, so starting with my professional background, I've been now in product safety and regulatory for almost now 5 years. I have a bachelor's in mechatronics and specialization in robotics. I'm a TÜV certified expert in machinery safety and also TÜV certified expert in CE marking. Part of the IEC initiative of the young professionals introduction into standardization and conformity assessment. I was selected as the IEC young professional in 2021, whereby we participated in a lot of working groups and technical committees as observer members to get the idea on conformity assessment and standardization. And currently I'm working in Thermo Fisher Scientific in the Netherlands, Eindhoven. Thermo Fisher Scientific is the market leader for transmission electron microscopes with various market introduction into semiconductor, life sciences and material sciences segment. And we are, let's say, working on with the introduction of various robotic systems with our systems. So there you have it, the professional background. I think we can go into the next slide. So I would like to start up with the challenges that are faced in the current industry, and also these various topics that are coming up quite frequently in the daily discussions. And starting off with the lack of unbiased data sets and data sets to support the AI safety product development, because AI safety product development does not only focus on the software, but also on the hardware implementations as well. And the challenges that are faced is how to verify if this, let's say, implementation, when it's going to go into the market introduction, is sufficient and acceptable. The other concern that we face is the uncertain impact on the social structure, how people are going to adapt or, let's say, cope up with the systems that are being implemented. For example, in the factory area or in the industrial segment, how will the interaction of a normal technician would be with a robot that's operating near it? Because it's not just the robotic arms that are operating in an industrial segment. It's multiple other types of machinery operating in and around. There could be overhead tracks. There could be other, let's say, elevated platforms operating over there. So that makes it a bit, let's say, challenging on how the normal community is going to adapt to that. And the idea behind it is, of course, not to replace the workforce. It's to, let's say, work together with these systems. The other point that I would like to highlight is the verification and validation frameworks with regard to AI safety implementations. These are, of course, you can say the verification might be a bit, let's say, possible, but validation might be a bit tricky, because again, you need to have unbiased data sets for that. The fourth point that I would like to highlight is the safety assessment for human robot interaction. As I mentioned on the social structure, on the interaction with that, that's indeed a challenge. And the last point that I would like to highlight is the lack of technical knowledge to assess the AI safety implementation. So from the developer point of view, the developer might be able to develop such a system, but he might face the challenge and the dilemma on how he's supposed to assess if this would be a safe system for the normal, let's say, surrounding environment, and also for the essential health and safety of the people that will be operating in and around there. Next slide, please. So thinking about some solutions that one can introduce is the introduction of guidelines and methodologies, or let's say frameworks for AI safety development. We know that we have a lot of standards that are used either with normative references or just informative references. And some of the standards could be the ISO 13849 and the ISO 10218 for the specifically for the robotics. But they over there, you will also find that there are some sections for the collaborative robots. But when it comes to AI systems, you would have to look at from the software development aspect as well, rather than also from the hardware aspect. So there should be some sort of hybrid standardization referencing to ensure, although this is currently done in the normal conformity assessment for systems in the market, that you use multiple standards for a particular system to comply, and those can be related to performance and those can be related to the safety as well. The other point I would like to highlight is training of the workforce for collaborative efforts. I think this is something that has to be introduced slowly and gradually in the industry, that people have to start adapting to these robots. And I think there are industries that are doing that. There are a lot of factories around the world that are currently doing this. They are probably done in an enclosed space where there is limited or restricted access for normal humans to operate where these robots are operating. But when the barrier comes off, how this interaction would be, because of course back on the mind you will have this question, will the robot come and harm you or something? So the training of the workforce is really essential over there. And of course, data sets preparation and also the contribution towards regulatory committees. So there should be regulatory committees founded in which they can ensure that the data that they're receiving from developers or from various manufacturers with collaboration is not unbiased, and also these data sets can be introduced and used by various other segments for the introduction of such let's say harmonized platforms in various sectors. Yeah, next slide, please. So this is basically an example on how the conformity assessment can look like or will look like. Of course, this is not in let's say a complete picture, but this does give an idea on how these conformity assessment would take shape once these systems starts to come into market, because of course you have to learn on the way on how to make sure that the system is developed according to the essential health and safety requirements. So you can start with the identification of standards and directives, which would be the leading part, and then slowly and gradually you have a short list of what type of standards and directive would your system have to comply. And then it comes to the assessment and evaluation of data sets, which probably would be filtered by the regulatory committees, which can be used by manufacturers for the development. And there can be multiple inputs, like for example, the AI Act that's there, and also from the application data sets for AI. And then slowly and gradually we'll move forward towards the product development for hardware and software. And there are multiple references that you can find nowadays from IEC standards, where you can use the famous V model for the development. And when it comes to product testing, of course, you need to ensure that you have the correct frameworks for testing and ensuring. So on software side, this might be very tricky because there are so many variables there. But somehow this is something that can be in the future tackled for the implementations. And then you go towards the conformity check, where the validation and verification checklist, like we normally use for the ISO standards, can also be introduced for these AI systems. And then eventually you go to the market with the product launch. Yep. Next slide, please. And lastly, I would like to conclude on how to go way forward. There are, let's say, millions of iterations and millions of implementations that one can go forward with. Some of them that I would like to identify is there should be some guidelines for tackling these AI safety systems issues in development, because we now know that there are AI systems being implemented, for example, chatbots for customer service and facial recognitions. But when it comes to actual implementations, for example, for self-driving cars and also for other systems, there should be some guidelines on how to tackle these issues. Of course, the important question that's currently being talked a lot about is this introduction of safety standards. As I mentioned, that there are ISO and IEC standards, but of course we need some hybrid standardization in between that can also tackle AI implementations as well. And lastly, it's a very important aspect is to start the introduction on the educational level for standardization and also the safety learning. And of course, I think now slowly and gradually, a lot of countries and a lot of startups are introducing, let's say, programming and also the benefits of AI and machine learning at educational or let's say kinder level. And I think this should be commonly now introduced across the world to make sure that there's sufficient technical knowledge to tackle this, and of course, the innovation would come afterwards. Next slide. Yes, thank you.
Perfect. Thank you very much, Adil. Very interesting, and especially the aspect of hybrid standardization. Probably we can elaborate later a little bit further on this. This is really interesting and probably specific to robotics. But now I would like to invite Aurélie for her talk. Aurélie, the floor is yours.
Hi, thank you for the invitation. So I'm Aurélie Clodic. I'm with La CNRS and ANITI, which stands for the Toulouse Artificial Intelligence Institute. Yes, okay. Next slide, please. Yes, regarding my background, I have a PhD in robotics, where I worked on a robot guide in a museum, mostly on the supervision part. And then I worked 4 years for an IT company working for Airbus, where I learned what does it mean to work with technical norms and related processes, such as the one Adil spoke about before, and also Continental Automotive. Until 2012, I work now as a research engineer at La CNRS, working on decisional aspect of human-robot interaction, and I'm responsible for the robotics team for ANITI. Next slide, please. So I work today on several projects, mostly international projects. So AI for HOI, which deals with knowledge models for interaction, which could be not only one-to-one, but one-to-many, as well as not only short-term, but also long-term interaction. ELSA project analyzes social affordances. Discutive project aims to study how dialogue models could take advantage of interaction models and vice versa. And the EPIC project explores how physiological data could be used in an HRI setting. Next slide, please. So regarding the challenges in human-robot interaction, I would say first to take care of data acquisition. So not only for data set, but I would say just for use. For example, in the AI for HI project, one of the scenario is in a retail store. So imagine if a robot acquires data in a retail store like speech, audio, or video. What if those data are stored? So perhaps we need to design systems to be able to forget or to delete data when they are not needed anymore. So get the fact, for example, that there is someone to avoid for the navigation system, but then erase the face of the person, etc. So just to say that there are new places where our privacy would be challenged with the introduction of robots. So we need to take care of that, I think. My second point is about data sharing. So robots can get information that could be sensitive. And if we imagine a robot that is able to speak, it is probably not intended that sensitive information are delivered to anybody, but just a restrictive set of persons. If we come back to the example before in the retail store, we can imagine that it is possible that the robot knows where is the retail store key, but it's in information that could be delivered to the other employees perhaps, but not to a customer. The third point is to take care of information that could be delivered. If we imagine that decision-making for such robots are piloted by big tech system, what if, for example, if your robot tells you for whom to vote at an election? So I think we need to take care which information should be delivered, who decides the limits, and of course, we need transparency, but at first perhaps to be clear about who pilots the decision-making system and what is the limits. There is a risk of manipulation that we need to take care about. Next slide, please. So regarding the next steps, I think we need to have formation either for the professional and the academic sector, but all challenges that have been cited and that will be cited in this workshop. In fact, one idea could be to set up a MOOC with a certification so professional can value it at workplace. But I think it's also something that Adil said, but we need to have formation about those facts. And I think also we need to communicate toward a general audience regarding what are the challenges. We need to inform about opportunities, but also risks that AI and robotics can bring. Next slide, please. And to end, I will emphasize the need to take care of vulnerable people, so like children or old people, etc. I cite a paper we did with people from the law side, analyzing what does it mean from the consumer law point of view. And since this workshop is more about industry, we should perhaps also analyze the implication from labor laws, the obligation of the employee, etc., regarding the use of AI and the introduction of robots at the workplace. Thank you, I'm done.
Thank you very much, Aurélie. Really interesting, especially the aspect of human-robot interaction. Robots are physical machines, and often they are embedded in our physical environment, so which is very unstructured, especially when humans are around. So I think the aspect of human-robot interaction probably will come later also in the discussion. And now I would like to invite Emmanuel Tehembwe to present his work. Emmanuel, the floor is yours.
Okay, can you hear me?
Yes, thank you.
All right, okay. Next slide, please. So yes, I'm Emmanuel Tehembwe. Completed a dual PhD in AI and robotics at Edinburgh University and Harvard University. Professionally, I do lead the UK branch of VDE, which is old, let's say, standard setting body. I'm also the chief AI architect of the VDE group. And as far as standardization activities go, I'm involved at PSIS, OECD, and even standard ICT. And of relevance to this panel, I guess there's quite a few projects. First is that been involved with the AI Trust standard, that the AI Trust label that we've built in collaboration with the industrial and academic partners at VDE. And this attempts to map the EU AI Act to a set of metrics by which, let's say, stakeholders in the AI community or the AI ecosystem can judge at least compliance to the AI Act. And also related to that is also involved with the AI Quality and Testing Hub, which is launching later on this year in collaboration with the Ministry of Hessen in Frankfurt. And there it's actually it's first contact to the real world on how to actually be able to test and certify AI systems that are used by real world companies against the standards and regulations that are out there. And recently we've also started off a similar initiative of a trust label when it comes to assisted driving technology, autonomous vehicle technology, to start thinking about aspects of what parts of the let's say advanced driver assist systems can be at least standardized, and we can attach some level of quality to them. And this is things like assisted parking or lane assist. Can we ensure that at least between if you go from one car maker to another car maker, there's no surprises in how your car decides to park itself, or so these are currently the ongoing projects that I'm involved with. Next slide, please. So I would say that one of the biggest challenges has been actually figuring out the work that's being done by the different groups around the world in this. It seems that it's still in early days, and different groups are exploring different avenues when it comes to robotic standards. And there is no kind of like overall map of the entire robot standards ecosystem. Recently, there's some work at some of the technical working groups or at like Stand ICT, for example, the robotics group there to kind of create a consolidated view of the standards world. And I think that there's an aspect there that awareness of what's all the standards that are available and applicable, not only from a legislative point of view, but also from if you're a startup or a company. Like I often run into companies who are like, we do not know exactly what which standards we should be testing against, and which should be applicable to us. And they ask for avenues, and if you're talking to most of these individuals, most of them are unaware of the intricacies of ISO, IEC. It would be nice to have a much nicer interface, especially for just general, the general, let's say, robotic startup or business world. So I think that awareness remains a challenge. Safety, I guess beyond putting robots in cages, and this was a point hit on by the last two speakers, typically safety was like we put a robot in a cage, or we have some kind of safety latch, or we have some laser scan, some hard mechanical way of ensuring safety. But increasingly, robots are actually out in the real world, and then going beyond just let's say the low risk applications of your vacuum cleaner, where failure is it just bumps into your leg or something like that, where you have systems where safety, the cost of failure is high and safety is paramount, and they're starting to think about how to actually create metrics that are easily interpretable for all the stakeholders involved within the AI ecosystem, and especially for these robots that are out in the real world, that are not protected by cages. That is a remaining challenge, and I think that's something that everyone's avidly working on. But again, still very challenging. And secondly, certificates of safety for, let's say, robotic systems that are running on data-driven methods. These are, when I say data-driven, I'm thinking more of you plug a neural network in there and you use something like reinforcement learning or whatever to actually get your robot to move around. Currently, there is the hope that you can always regress down to some kind of mechanical safety gadget. But increasingly, I've seen recently, for example, this work coming out of, I think, ETH Zurich, which is Marco Hatter's group. Before, we never thought RL would work for a long time in robotics. And now they have a robot that's basically trained in simulation and runs around and is able to 1 hour autonomously run up and down a mountain using RL. And when you start thinking about the safety of such a system where everything there is no concrete model of its behavior and everything is learned via data, via simulation, having a certificate of safety that this robot's not going to behave in a particular type of way in a particular environment that could cause danger to humans around it is an open question. And I think that that's something to at least investigate. There's a question of whether it's possible. Some people say it's not, but I think it's at least worthwhile investigating. If we can't get a hard certificate, maybe we can get like a probabilistic one that we have some bounds on the behavior that with, I don't know, 99% chance it won't do some strange behavior in a particular environment. And then the last challenge, I guess, I would say that it needs to be considered right now is the autonomous car industry and the technologies around autonomous cars. Often, I guess there is this aspect that we're hoping that that there is a hope that the car self-standardize, the car industry kind of comes together and builds their own, kind of safety standards and metrics around this. But in practice, what I've ended up seeing, at least talking to a lot of the startups here, is that first of all, there is no rules, so they're like just taking at least their own initiative, which is a little bit concerning. And I see this not only in from the American, let's say, autonomous car industry companies, the American companies developing autonomous car technologies, but also from UK and wider Europe startups in this area. And beyond just thinking about safety, it's also a question about opening up the industry, opening up the field to let companies more securely, deploy their technologies, because a lot of them they might be doing something interesting, but if there is no standard around it, then the liability costs are too high for them to actually fully explore without restraint. So there's this conversation to be had with this entire sector that I think is currently being underplayed by the legislative, but also the standardization world in general. Next slide, please. So yeah, touching back to the point that I brought up earlier, it would be nice to have an easily navigable and central repository of robotic standards, and not only for standardization world, but for everyone, all the stakeholders around that. And I'm thinking particularly of SMEs and startups who increasingly are, finding that they are ready to, work on some particular product or deploy some particular product, and then figure out that later there is a standard that was applicable that they had not considered at inception. So it'd be good to have that. And I would also say that we need a more kind of coherent European roadmap on what we're going to do regarding autonomous cars, because as it seems to be right now, this is possibly the largest deployment of intelligent robots that's happening in probably our lifetime, and it is still sitting on the wayside. And then yes, next steps is at least concretely, when I'm looking at some of the stuff that is coming out of at least literally hot off the press, let's say out of the research world, it's that recently, as it seems that for data-driven methods like RL methods, they've congregated around particular simulation tools to build to at least train their robots in simulation. They seem to have slowly come around almost like a homogeneous or standardized pipeline for actually how to use, how to train their AI models, but the AI controllers for these robots. And it would be interesting at least to start seeing, is there an avenue where we can actually at least take some of the tools here and agree that, okay, that if you are going to be deploying a system in this place, then it must, at least we have some kind of standardized testing environment, assuming that this gives like a first point of contact to see how well you conform to safety standards beyond just real world testing, which is always quite expensive. It seems that simulated testing has become, at least in the last 2 years, it's become good enough that, yeah, I give the example. They trained a robot in simulation and they was able to run around for an hour in the hills of Switzerland. So it's at least good enough that we can start thinking about testing environments, standard testing environments around there. And related to that, if we have standard simulators and standard testing environments, maybe we can automate aspects of testing for this for particular, let's say, industries like autonomous cars or let's say quadrupedal robots that are delivering pizzas or something like that. And so, yeah, that's I think that's my talk. Next slide, please. Yeah, thank you very much.
Perfect. Thank you very much, Emmanuel. Really interesting indeed robots seems to exit their caves nowadays, and you mentioned really interesting examples. I'm really curious to listen a little bit more, probably later, about the use of simulation as a tool for testing, standardized testing. That probably this seems to be like a first step towards standardization, but sometimes I'm wondering about the ecological validity of such an environment, and how, I mean, we can discuss later about this, but I'm really curious about this aspect. And lastly, we have one more talk from Roland. Roland, the floor is yours.
Thank you, everyone. Hello, and yeah, welcome to this panel discussion. Next slide, please. My name is Roland Behrens. As you can see on the first slide, I have a background in mechatronics and robotics since 13 years now, and I'm with Fraunhofer IFF. I'm pretty sure that you are familiar with Fraunhofer, so a huge society for applied research. And what we're doing here in Magdeburg is mostly robotics. And I'm personally specialized in the field of robotic safety and safe human-robot collaboration. And I did my PhD in this field. And I did a lot of volunteer testing in the past in order to determine biomechanical limit values. Now we're using the findings and the data from these tests to create models to make robots even safer. Right now, or most recently, I became the convener, a convener in ISO TC299, which is the technical committee for robotics in the ISO landscape. And I am responsible there for working group 8, which was created to define new validation methods for collaborative applications. My most recent projects is the ISO PAS. So right now we are working in this working group on an ISO PAS 5672, which will a normative ISO deliverable, and it will set forth test methods for measuring forces and pressures in human robot contacts and collisions. And I have also a lot of EU funded projects. The most recent one was Rossini, which was mostly about making it easier to deploy collaborative robots, and our part there was to create models which to make collaborative applications safer. Next slide, please. So challenges. So when we talk about AI, I have always sensors in my mind which using AI capabilities, And here the question is, how can we make these sensors safe? And I am seeing here a huge challenge, because right now, what we're doing with the safety rated sensors, we have standardized testing, we need to verify them, we have these performance levels, these seal levels. We will see this on the next slide. So, and here, the big question is, how can we ensure the same integrity level for AI empowered sensors? And one solution we are recently working on is model-based safety validation. So, as you know, I'm the convener of these new working group in ISO, and so right now the project we are working on is about measuring, but I'm pretty sure the future are model-based validation methodologies. And of course, what the good thing is, if you have model-based methods, you can create them so that they are still within the boundaries of existing standards. And my recommendation here might be to think about smart safety. We called it smart safety, which could be, I know this is very controversial here, but maybe a kind of a high frequency CE. When we're doing this certification of an application, it's a huge process. It took a lot of time. It's time consuming. It's not fun actually. And when we think about AI empowered robots, the question is, can I anticipate what the robot is doing in, let's say, half a year? Because the robot is learning during the operation when the robot is completing task, and maybe the conditions are changing and the robot is adapting. And the question then is the CE still valid, which was manually approved? And here, what we have in mind, and we are already have some concepts for that. So we call it instantaneous certification of micro actions. So whenever a robot is doing or will execute an action, we have a small micro CE process which ensures that this kind of action, which was decided by the robot, that this is still within the machinery directives and all the other directives and regulations which needs to be applied. Next slide, please. And what could be the next steps? So we are thinking about, or what we would like to have is an acceleration of the standardization processes. So we need to be more agile. As you know, as a convener in ISO, I see how long it takes to create a standard, and it's the same process like 20 years ago or maybe 40. So you have a group of experts, you're discussing a certain topic, and then you need to find a consensus. And then at the end, there will be a document, and to update this document, this will take time again. So the process is very rigid. I guess it's not very good for the needs we have today, especially if it comes to AI. We see so much progress in this field, and so the standardization processes we have now, they kind of make pace with these progresses in an AI. And what I would like to have here is an agile standardization instead of these decade-wise updates. What I can imagine is that we have, let's say, a standard, and one section will be updated, let's say, within 3 months in an agile process with sprints, with backlogs, so a Scrum-based approach. And this standard is not a document, but it's more like a web page or whatever behind a paywall, maybe like that. But then we have always the possibility to update it, pieces of it, and to keep it in general very close to the state of the art. Then what we also need are clear and robust metrics, which allows us to validate the reliability of AI empowered safeties, especially if these sensors should be safety rated. So we need to find a way ways that ensure us that the sensor, which is made for safety purposes, that this is kind of validated or verified. So we need to find ways here. This is a very complex task, and we have some concepts, but not the groundbreaking idea here, to be honest. Maybe safety assurance cases can be approached. It's an alternative to these ZEAL and PL processes. So they are already used in autonomous driving. So this is completely different principle to prove that a certain safety related part will work within certain boundaries. And of course, last point, we need more model-based approaches to validate if maybe an action which was created or planned based on AI capabilities, that this is tested or validated before it is executed by the robot or the machine we are talking about. So that's it from my side. I guess that's the last slide is just a thank you, and I'm looking forward to the discussion.
Thank you very much, Roland. Really interesting concept that what you mentioned about smart safety. Probably we can elaborate a little bit on that later. It seems, indeed, probably it's expensive and time consuming, but probably there are aspects that can be accelerated in the future somehow. Thank you very much for your talk. So it seems that our audience is not very active, so we don't really have questions from the audience. So then since we have approximately half an hour for our session, I would suggest instead, I already have some questions myself, but I would suggest that we have the mural on our screen. And I can explain you, and we can base our discussion on the framework that we have developed. So this is based on the literature. We have a matrix where we have some elements I can explain later. But before that, we have a space on brainstorming. So I would say that for now we focus on that. Yesterday, I just prepared some sticky notes based on your slides. Those are concepts that you mentioned, and I tried just to categorize them mainly in challenges or needs with a yellow color, and proposal solutions with the blue color. But this is only my interpretation, so we can change as we want, and etc. But probably we can start the discussion on the topics, unless you want to raise something yourself. But I would say that during your presentation, there were some topics that I thought that might be interesting for the audience. For example, Adil mentioned about this hybrid standardization. So Adil, would you like to elaborate a little bit on this, and probably highlight notions that and concepts that are already in the sticky notes here in the mural? But I mean, you can just elaborate in 1 or 2 minutes on the hybrid standardization concept that you mentioned on your talk.
You're muted.
Oh yeah, sorry. Just saw that. Yes, thanks, Vicky. So what I'm stated with the hybrid standardization is, I think it would come out from the point of the identification of the standards and looking at some of the standards that you've already stated on the right side for the ISO, for the machinery and the robotics. And I think what I mentioned in the presentation as well, that these standards are already done in the similar way, where there is a normative reference into ensuring a progressive development or safety development of the particular system. And then you follow up with the introduction of other standards with regards to risk assessment, safety risk assessment, and also validation. And when you look at the checklists for the safety requirements, these also would come out from these combination of these standards. Of course, the standards that are already there do not have direct reference to AI systems, but I think there should be a direct relation towards an AI standard that is able to validate and verify that.
Yeah, thank you very much. That means also that probably if we move to the matrix, for example, we have Philip, can we have the matrix on our screen, please? Yes. So because you mentioned about different standards, and then immediately came to my mind the first column on terminology. I can briefly explain this for our audience. So this is based on the literature on standardization, and on the x-axis, on the horizontal axis, we have identified some concepts. First of all, we have terminology, and we're discussing about, for example, different standards, and then and also research and industry people, etc. And what we want to make sure is that there is a common taxonomy and terminology where people can communicate in an adequate way. Then we have the measurement or metrology, where we want to have specific objective metrics in order to proceed to standardization and validation of the systems. And performance characterization, this is related to metrics, of course, so we need objective metrics, but also here in the performance characterization, we have subjective metrics, for example, from the user, the end user, etc. Then compatibility of the system and the standards that we develop with existing with existing regulation, probably. And this is, and finally, the conformity assessment, for example, in AI Act that we are currently preparing at the European Commission. It will be launched in some months from now. And we want to make sure that standardization that it is developed in different organizations conforms with the requirements from AI Act. And on the vertical axis, we have three main steps in the development of the system. The data creation, we need the data to develop our models. Then the development of the model, the AI system, and the production. And finally, the deployment and the marketing, so probably monitoring of the system. So across this, in this matrix, we will try now in this session to apply the concepts that you mentioned already. For example, Adil, you mentioned the different standards and for the hybrid standardization, and I suppose that this is something that probably relates to terminology. But if you want to elaborate further on this, would you like to elaborate further on this in relation to the matrix that we have now in our screen?
There isn't much to elaborate on that, but I think that is indeed correct on the terminology that we use for the hybrid standardization, and it should be well known on how and what does hybrid standardization mean, and is this something that should always be introduced during the safety development, or is it something of much more of an informative reference that we can have? And also, I think the hybridization can be used for the performance characterization as well, and also during the conformity assessment, because it's a combination that you need to have during the safety development, because every system that's placed on the market does not conform or comply with just one standard. It's a combination of a lot of standards that are used, but they are used as, let's say, not defined for that particular system. Those are type C standards, but it's a combination of little references to those standards.
Oh yeah, thank you very much. And then in the first level, we have the data creation, and I think Aurélie, you talked about the data creation. Would you like and especially, I mean, you mentioned also, for example, unintended data collection because of robots that might navigate in a human environment or vulnerable populations. So, would you like to elaborate a little bit more on this, Aurélie?
Yes, it was mostly on the fact that, yes, we talk about data set creation, and of course there are bias and all that stuff that needs to be taken into account. But I think also that, yes, during the use of the robot, the fact that the robot can collect a lot of data during its use, we should take care of that also, perhaps in the design of the robot, to think about what should be done with those data, because it means that there are other locations where our privacy would be challenged, and so we need to have a look on that, I think.
Indeed. And yeah, privacy.
I think, for example, for now on the internet, we now begin to know that our data are still everywhere, and so we need to take care of that. But it's kind of, yeah, it happens after, at least on my side, and I'm even not sure that we are aware of everything that are done with our data. So perhaps we need to think about this before it happens and take care of that before the problem arises. Yes.
Yeah, and since we are talking about data, probably any other is there any other comment about the data collection or data creation from the rest of the panelists? Okay, if not, then we can proceed to the next one about the AI system creation and production. Roland, you mentioned about this smart safety, and I think that this is probably I would, according to my interpretation, I would locate this process probably in the AI system creation.
Yes.
Is this correct?
Yeah, I agree. Absolutely.
Would you like to elaborate a little bit on this?
Yes. So as I said in the presentation, so what we can imagine is that smart safety is a door opener to AI-empowered robot systems. So right now we have, I mean, what we're doing actually when we setting up collaborative robots, which are working with the safeguarding mode force limiting, that we're doing measurements. It's just an example. So we're doing measurements of collision forces and pressures and so on. And this is, I mean, at the end, this measuring instrument is a very bad model of the human body. And here we are already working with models, but we're still doing these measurements. And I mean, digital models in a simulation, they can do much, much better and can be more precise. And this is under the umbrella of smart safety, to have the possibility to use models for simulation-based validation. And this can be an important cornerstone or keystone for AI-empowered robots. So whenever a robot is deciding to execute an action or is planning an action, then we can use these model-based methods to check whether this action or the plan is within the safety boundaries, and if not, the robot is not allowed to execute this action. And this is what we understand under smart safety. But there's more. What we can also imagine is that the robot, when we're talking about robots, that the robot has an understanding of the standards. You know, when I buy a cobot today, it's very easy to program it. It's very easy to deploy it. But at the end, to ensure or to prove that it is safe, it's still the same as for other machines. And here we need to make it easier, and by putting some of the knowledge which is in the standards or the requirements into the robot. So the robot has to tell the user, hey, look, there might be a hazard of pinching points, which can be there and there. Have you considered this? Yes or no? So like this. So we have this checklist here, and the box below. Checklists are cool, but at the end, the system must tell the user what the user has to do, and then we make it smart, we make it more easier to deploy it. Because easy programming is one part, but at the end, we need to ensure that it's safe, and there we need also technologies or whatever which simplifies this part of the system deployment.
Yeah, and I suppose that this depends on the application, right? So, for example, Emmanuel mentioned driving vehicles. So there probably things might be a little bit different, right? So in terms of safety, or
yeah, I agree. But at the end, if you look to the companies which are already using cobots. So cobots is I have a lot of expertise in this field, so that's my first example. So 80% of the applications are always the same. It's just pick and place, so transporting materials from A to B. And I mean, if you can simplify this safety process for this 80%, of course you will create an advantage for these end users and also for the cobots. So the reason why cobots are not hit the market like we anticipated it 10 years ago is because the safety to ensure that the robots are safe and the certification and so on, it's too complex for these machines which are made to be easy. I mean, at the end, let's look into the future. In 20 years, when I buy an autonomous car, I'm pretty sure that I am, as an end user, I still need a driver license. It's fine, but I don't need to know what can happen with the car. So all the entire knowledge, all the requirements, they are in the car, and the manufacturer take care of this. So it's done. I mean, here, smartphone. Have you ever read the safety advices for the smartphone? No, I never did this. And that's the same for machines like robots, which are used in an industrial setting. It should be the same. That's at least my opinion.
Of course, yeah, of course. But I mean, we are all aware about the current discussions quite on explainability, right? So people now are trying to understand, especially in explainability in terms of the user interaction, right? So what the user should know, when to know, what to know, etc. And this is something again that we need further research. You know, it's as you said, I mean, we don't know exactly what is happening in our smartphones, but especially with robots, if I may say, because of my background in social robotics, we observe exactly, you know, a kind of polarization, because we have in some cases overtrust because of you know, some social robots look very cute, etc. And then depending on the population and the user, we have studies that show that even when a robot, I mean, on purpose makes mistakes, still the user would trust the robot. So there we still need to find the sweet spot, right? So
that's true.
Yeah, but Emmanuel, probably you can elaborate.
There was a question from
Sure.
Ellie, maybe.
Is there a question?
It was just a short one, if I may.
Sorry, yeah.
It was just a question for Roland about this certification. Do you think it could be a self-certification, or do we need an external certification? Do you think that robot provider can self-assess that it's okay, or do you think we need?
That's a good question, actually. So what we can imagine for a step in between the full automated self-assessment or certification could be, so let's say we keep the human in the loop for the critical parts, to say, okay, please look, you have this application here. I have some context because I know the robot program. And maybe at this point we can take the user in the loop by saying, okay, when you're programming the robot, please tell me also the hazards, because you know the application, you know it, and you know also the hazards, and please tell me, you know, as a robot. And then you can make it assisted, I would say, assisted certification process with the focus on the risk assessment. So this could be one approach. But at the end, I can imagine that we have also the possibility to do some self certification or automated certification whenever we have an application where the boundaries are clear, you know. But of course, there is a huge diversity of applications, and but a step towards full automated certification could be assisted, mostly assisted certification process.
Okay, so I like very much the idea of checklist that the robot could express and the human can check, because there is a lot of problem with expectation of the human, as Vicky said. And I think this kind of stuff at the beginning of the interaction could be helpful. I think I like very much the idea. I like in the plane, you have this checklist at the beginning. Thank you.
Yeah, in fact, yesterday also it was mentioned in one of the workshops about this, you know, some even simple checklists, you know, for the user, you know, to be able to easily apply. But I would like also to bring in the discussion, Emmanuel, and the self-driving vehicles, because you have experience in this. And looking again in our matrix, my impression is that what you were describing beforehand, Emmanuel, is a little bit transversal into, you know, this matrix in a vertical and horizontal way. So would you like to elaborate a little bit more on the ways that we could go forward for the standardization for self-driving vehicles, which is one of the most complex, I think, applications that we currently have?
Sure. So yes, when you start looking at self-driving cars, and how everyone's conceptually marketing them and all the hype, and, you know, trying to tear that down into what the capabilities are, and, you know, where where the real need is right now and what's possible, technically possible, versus because there's an aspect of the dreams of what you hope is possible, but then there's the reality of what's actually possible right now and what's actually being deployed. So on the one hand, you have the extreme cases like I would say probably Tesla, who's just like we will deploy and we hope that we've got enough data to cover most of the cases in the real world. And interestingly, it was one of those things that we were wondering what, like, at least initially when I saw this happen, I was wondering what would happen when people are killed by self-driving cars. And now that's happened a couple of times. And it seems that, at least in the American market, that's at least raised some concerns, but people are still using the self-driving technologies and they're not completely terrified by it. In Europe, otherwise, and I guess around the world, is that not gone as extreme as saying that, yes, you have full self-driving on your car and you can just install it. But what's happening is there's a slow seeping in of, instead of calling it self-driving, I guess you call it assisted driving, advanced assisted driving technologies, ADAS systems. And yeah, these are on the road to self-driving, but they don't promise self-driving, so to speak, but they do have aspects of it. You have aspects of intelligence being ingrained into the everyday driving process. And so when we started looking at that work, we started to say, okay, so what are the applications we see? We see, for example, lane assist. That's one that seems to be consistent among all the manufacturers, that they're all developing their own, let's say, models and algorithms for for assisting with lane keeping. And then the next thing we kind of, I guess, exploring this area we saw is that there's all this talk about like assisted parking, autonomous parking, that you get out your car. Even if right now, I don't think there's many manufacturers that actually let you get out your car and let it park, but they do have aspects where the cars are now capable of parking themselves. And then the question comes out of quality as a consumer. Again, looking at as a consumer, if you buy a car and you're driving, let's say, I don't know, one model, a BMW 1 year, and then you go and take out a Volkswagen the next year, you'd want to assure the consistency if you learn an expectation of what a car it should do when it's parking itself. There shouldn't be some kind of surprise when you go between different manufacturers and different car providers. So this is where the discussion honed in. It was like, what are the small concrete areas in which we're seeing mass deployment of these technologies, where there could be, let's say, especially where there could be a potentially dangerous situation where the cost of failure is high, but there is consensus that this is something that could be standardized technically, and also that's technically possible, but also there's will from all the stakeholders, because they do want people to start using these technologies. And so, yeah, this is what led to this idea of some kind of trust label around the assisted driving technology, so that we can ensure conformity around working in partnership with not only academics, but also industrial partners and also traditional car testing companies, to be like, okay, maybe this is something you should be thinking of. You should be thinking about if you are doing car safety in general. And so around this area, this is where, when you go from that, you think about, okay, what kind of sensors should we certify? Sensors, for example, because cameras, for example, they through usage, they degrade in quality. And if you have an AI system hooked up into that, and a speck of dust or a scratch in the glass creates a potential for systematic kind of like failure for high, then that means that, okay, that your entire, let's say, lane assist stack is now compromised, and your car is not able to reliably detect one side of the road, and it's likely to veer off. And so this is still very early days, but we're in discussions of like, okay, so how can we, for example, standardize sensors on? Can we certify sensors for particular cars and environments? How regularly should we test? Is there like a grade of damage at which we should reconsider testing? Should this be part of the regular car safety checks, the annual car safety checks. Like as we check your mechanical safety, should we also take the sensors that you have on board and the safety and if let's say the assisted driving technology is still reliable with the degradation in usage, which is something that I think is more extreme in cars than it is in a factory environment where you don't have really depending on the driver, depending on the environment, you'll end up with degradation in sensors more so in one area, in one, let's say, geographical area than another. And then crucially, can we not only streamline this process to the benefit of the end consumer, but can we also provide tools to let's say industrial partners and researchers working on this? And this is what we're talking about. If, for example, if you're deploying a sensor, can we have an environment where we can put it into a set of autonomous cars and see if it, we're able to basically go and simulate as much the environment in which we expect the car to operate, for example, and see, basically kind of build an entire ecosystem and I guess put together the entire ecosystem of sensor manufacturers to car manufacturers to all the other societal stakeholders like the car testing companies and the regulators and the consumers to be like, okay, now we have something that we can say is trusted, like we can have a car that is trust with high probability is not going to to veer off the road if one camera is blocked or 2 or 3 cameras. And if that happens, then there is some kind of alert mechanism that says, okay, my trust in these sensors has gone down to the point where I need to take the car in and have these rechecked or replaced or something like that. Yeah. So I don't know if that answers your question, but
yeah,
it's kind of an overview of the current issue. It's very complex.
It is very complex, and in fact, with your description, I saw that. If we want to map what you said into this matrix, I think this really covers quite many aspects of this matrix. But we only have 6 minutes for until the end of our session, and I would like to go faster into the third space of our mural, which is the prioritization area. And Philippe, if you could switch to the exactly. Thank you very much. So here we have another matrix where we tried to represent the feasibility and the importance of a concept that you think that it's really difficult or important, is important, difficult and not so important, and easy but not so important to implement. And since we only have 5 minutes, I would like to give you to give 1 minute to each of you to elaborate on one concept. Probably we can focus on the important ones since we don't have much time. Difficult and important, or is important, and to elaborate in 1 minute. So you can choose whatever you want from your work that relates to the next steps and solutions for standardization in the area of robotics. I don't know, Aurélie, would you like to start?
Yes, I think we all agree about the fact that we need to form people to have formation either for the professional and for the academic sector, and also to the general public about the use of AI and the risks that could happen with that everywhere, in fact, in the workplace, but also at home. So yeah, I think, yeah, perhaps it's easy. I don't know if it's easy, but I think it's important.
Yeah, but indeed, yeah, Roland?
Yeah, when I can make a wish, I would say that the model-based safety validation is a topic which has a high importance, because it can be a door opener for AI-empowered robots which are planning their actions themselves. And I mean, it's something between easy and difficult. So, I mean, we have models from the research. These are very nice. They are working precisely, but of course, we need to adapt them. We need to bring them into the standards. And this is something between, let's say, difficult and easy.
Thank you. Thank you very much. Adil?
Yes, I think I would like to state the standards, the identification, the implementation for the standards. I think that's a difficult one and an important one, because we need to have those standards in place, because that would be, let's say, a way forward for various developers and manufacturers in all the industries to have these guidelines, to at least they can start with the development.
So you mean to start with some guidelines and then eventually to develop those guidelines into standards?
Those guidelines, yes, those guidelines can be somehow, of course, I think the whole standardization process does take time, but at least there are some defined guidelines that are accepted and regulated, which the manufacturers can use for further developments.
But can I ask about which topic? This was not clear to me.
Guidelines. Adil, do you want to talk about the specific application, or you mean generally in robotics in the area?
I think generally in robotics and in other industries as well. Yeah.
Sure.
So it's more for overlap. Yeah.
Yeah. Emmanuel?
Yeah, so I'll add to that elastic guidelines and checklists. I think that's important in general for this. And then I will actually also add a little bit, but a corollary to basically Roland's point of, I guess, some kind of thinking about standards, not around model-based approaches. I'm actually more interested about the model-free ones now, because it seems that, especially over the last year, a convergence of factors has led to an explosion of momentum and work there, which means that we have to start. At least it's not something that can be ignored. So I think that there is an aspect where we have to think about safety and validation of data-driven methods specifically, completely data-driven, as in no model in between. That's the only thing I could see.
Perfect. Okay, so I think we are just in time.
Vicky, one remark. Andreas, can you please correct model-based safety validation? Model-based is very important. That's missing in my sticky note.
Model-based is
model-based. Yeah, that's a key word here. Thanks.
Okay.
Excellent. Thanks.
Okay, thank you very much. Thank you for the correction. Great. So then I would like now to close the session. Thank you very much for your contributions, your presentations, and the discussion. Later, we will have in a plenary. I will try in 5 minutes to capture what we discussed today, and most likely we will come back to you for some further elaborations. And thanks for the audience also to be with us. And I wish you a great day for the rest of the conference. Thank you.
Thanks, Vicky, for the organization.
Thank you.
Bye-bye, everyone.
Bye.
Take care. Bye-bye.